Oops, that's not the right screen. Let's see. Let's just move that on over. It's not doing anybody any good over there. Let's get rid of this one as well. Okay, welcome everybody. Welcome on in, whether you're in Zoom or on the YouTube stream, either way. Welcome. Good job everybody putting their name in there. That's going to make it quicker when I go through and do roll in a few minutes. And we'll take care of stuff. So, a few things that I want to talk about as we get started. Let me just make sure. Yeah, oops. Looks like I'm back on this screen again still. That's not what I meant to do. There we go. Okay, so I did get some emails about problems that people wanted to see done. So we'll go over those and a couple other questions. So one thing, just a heads up for you as well. If you email me, and sometimes, like if I get that email, it's not always the case, but like I got it, like the thing I'm about to talk about in a minute. I got an email question about this or a Canvas notification. So sometimes instead of responding directly, I'm just going to talk about it in class, because then whoever asks the question will get their answer, but also probably everyone else needs to hear it too. So when I get an email where someone's asking a question that like I should just tell everyone, I just wait and go over it in class. So there's the problems that people sent me that are actually like homework problems, and of course I'm going to go over those. But then there were, if sometimes there's another question, like there's a question about the exam. So I'll just go over those, or I'll cover that question in class. So you might not get a response, but then it's talked about in class the next time. So you're still getting your answer, just maybe not directly in that form of an email. So let's see. So I've got, where's my list of things I want to go through? Yes, right. So we'll go through those problems in a second. We're kind of wrapping up chapter 2 today. I'm hoping to get into chapter 3 because we're just going to have sort of limited time here. The actual test date, if you're taking the, so anyways, let's not get ahead of ourselves. I'll go through all that in detail as we go through this. But the question that I got was about the practice exam. So that has been posted. So I just want you to know, if you go down to the end of chapter 2 here, it says practice exam. So you'll click that. And then I just tell you a little bit of information about it. Basically, I will post the solutions to the practice exam, but I don't do it right away. I kind of do it at the end, like right before the test comes out, like shortly before the actual test, because what I find is if I give out the whole point of a practice test is for you to practice, right? But if I give out the solutions right away, then what happens is people just go look at the solutions, and it's like, for that you might as well just look in your book, right? If you're going to look how a problem is done, just look how the problem is done in the book. The whole point of the practice test is for you to practice, for you to test yourself. Could I have done this problem if it was on the test? And if not, to try to work through it a little bit. It's so much better to work through problems than to just see the solution. You're not really going to learn it, right? It's just the same as watching me do, like when we have in class, on ground classes, a lot of times there's students who just want to see me do example problems on the board for 2 hours straight, like just nonstop problems. The problem is research shows you don't really learn that way, right? You might feel like you've done something because you go, oh, I completed the practice exam, but kind of I completed it. You just looked at my solutions, right? That's not really learning. So in order to learn it, you have to push yourself through the problems. You have to do that. And so that's why I wait. In fact, most of the times in class, I don't even give out a solutions to the practice test. I say, hey, you guys got to figure it out, right? Either figure it out with each other, figure it out on Discord, figure it out in study groups, figure it out with the tutors, whatever it is that you got to figure out, to get those solutions, do it. Now, it's a little different because with an online course like this, it's a little harder to kind of meet up in the same way as if 5 of you after class say, hey, let's go to the tutoring center and work on this together. It's a little bit different. So I will post grades, but just be aware they'll get posted like not too far in advance of the actual exam. So just be aware of that. The actual exam is a week from today on the 7th. So we'll go through all that. So the practice exam is posted below. It's a PDF here. You click it, and you know how PDF works. So notice how it's labeled Exam 1 Practice at the top, so you won't mix it up with the actual test, right? You've got some information here, and then you've got sample problems, right? So you can look at all these sample problems. So what I would, here's the perfect scenario. You print this out and you work like soon, but although we haven't really covered chapter 3, so you can't do all of it, but you could start some of it, print this out, and then start working on it, right? And then the problems that you ace, you're like, oh, I know how to do this one, I'm really good at it. And then you're able to finish it, you check your work, everything checks out, you're good to go. Make a little note by that problem, be like a little smiley face or whatever you want to make you feel good like you did it. Just kind of note that problem was easy and you've got it taken care of. And then the problems that you struggle with or you don't know how to do, make some kind of other note by those problems, right? But then you've worked through the thing. Then what you should do is get together with other people. Get together on Discord, get together in Zoom, get together in person, right? Go to the tutor center. There's lots of outlets for you to get help with those problems that you didn't know how to do. If you work through them in that kind of way, you're going to learn them so much better than just looking at the solutions, right? It's just not really effective at all. For like 90% of students, reading solutions is not really going to be helpful for you. So then get together in groups, get together in Discord, get together wherever and work through that stuff so that you know how to do those problems and similar problems, right? I reserve the right to change the problems. Now, I don't it's not going to be like a whole different test, but some of the problems are changed in very subtle ways. Some of the times I go in and I take the problem and I literally just change some of the numbers to different numbers so that it doesn't come out exactly like it did on the practice test. And then sometimes I take a problem and switch it out for a totally different problem, but maybe from the same section. So it's not exactly the same directions. It's not exactly the same thing. But if you know how to do the stuff from that section, you'll be fine. In other words, what I'm getting at is sometimes people look at the practice and test and say, oh, on the test, he's only going to ask exactly these problems and nothing any different. And the fact is, they will all be at least a little different. They will have at least some different numbers in them. And some of them will just be different problems. Okay, but by and large, this will give you a pretty good indication of what material you need to learn for the exam. And in this case, the exam is pretty similar to the test. I wrote both of them this morning. So they are similar, right? But just be aware there's some differences. Whoops, I didn't set these right. Why didn't that work? Is Zoom not working or what's going on? That's weird. The Zoom meeting is doing something weird. Hopefully it's working properly. I don't know what's going on there. So you can print out your practice test. Now, like I said, we haven't even finished chapter 2, and we certainly haven't gotten into chapter 3. But that's kind of the thing, is in the summer, everything moves so fast. So just be aware of that. So you can look on here, look at the types of problems. I can pretty much tell you you're going to do problems like these on the tests. Like this one, solve this 4th degree polynomial equation. We learned this in chapter 3. You're going to learn to solve more complicated, higher degree polynomials. You'll definitely have a problem like that. A long division problem. We haven't talked about division, but we'll sort of address it. I talked about this. A lot of this class is looking at the algebra, figuring out what that means for the graph, looking at the graph, figuring out what that means for the algebra. Here's an example of that. Right, so we'll look at some different examples of things going on. Finding an inverse will definitely be on the test, and probably it will be finding the inverse of a rational function. Oh, I have a typo here. That should have said f of x on there. That's a little typo. Sorry. And then stuff that looks a little more familiar, difference quotient, odd, even, we talked about last time. Piecewise functions, you're going to have to graph a piecewise function on the test. I tell you right now, it's going to be on there. So know how to do it. I'm always kind of amazed, and this is one of the reasons I always put it on there, is even when I tell a class, you're going to have to graph a piecewise function on the exam, I still get about half the class not able to graph a piecewise function. So I'm just telling you right now, you will have to graph a piecewise function on the test, so just learn how to do it, and then you'll go, oh, that was an easy 10 points, and it's all much better. And then circles, we'll talk about circles, okay? So there's that. So the practice test is up. Feel free to use it however you feel you need to. Yeah, let's go ahead and talk about exam 1 then when it's there. So I've opened this section of chapter 3. I'm hoping to have all of chapter 3 open. I'll be opening it up over the next couple days as I get all that stuff up. And I'll talk about that in just a second. But as far as exam 1, so you have 3 options on how you're going to take exam 1. Okay. The preferred method that I would kind of like, but I realize it's not possible since you signed up for an online class. The procedure that I'm kind of hoping people do is you set up an appointment in the testing center and you go take the test in there. That would kind of be the best. That's sort of the most legitimized way of doing it. I have a link here to the testing center. So here's the thing about the testing center. Like, I've sent them the information, so they should start accepting appointments. But here's what you have to understand about the testing center. You have to have an appointment, and you can't just show up and make the appointment, okay? So that's why I've linked here to the page. In fact, let's take a look at it. If you look at the link, this is the testing center on Ventura College. We've got their hours, Monday, Tuesday hours, Wednesday, Thursday hours. Okay, pretty generous hours, but you have to have an appointment. So you can call them, but here's the thing about calling them. You have to call them during their normal hours because otherwise no one's there. And then also, sometimes even during hours, they don't pick up the phone because they're like proctoring exams, and so sometimes they can't answer the phone. So what you can do, the best way is to email them, is what I've found from students. Email them, and then you might have to email them a few times. Make sure you're staying on top of it, because if you don't get an appointment made, you can't take the test this way. You have until the 11th to take the test this way, so you get a few extra days if you're gonna set it up this way. So that kind of give you the weekend to study, and then I let you take the test on Monday, and then Tuesday we're gonna move forward with everything. So email them, make sure you set up the appointment. You might have to email them more than once, kind of stick with it a little bit. The location is ELC1. This is in that little parking lot on campus that's kind of elevated. You would go up some stairs to walk there. For those of you who are familiar with campus, it's kind of over near the Performing Arts building. It's on the Loma Vista side of things. So it's the little parking lot near the Performance Art building, not the huge parking lot that's over there. Yeah, so a good question there. I'll get to in just a second. So so that's where it is. Just pull up a campus map. In fact, here, if you take this ELC1 location and you open it in a link, it literally just takes you to it shows you what the building looks like, kind of a gross building. It looks kind of like a jail or something. It's not like anything anyone would want to spend time in, but for testing, that's fine. So it shows you the building. Here's that parking lot I was telling you about. If you were to keep walking past, you'd walk to the building, and then it shows you where it is on on an actual map. It kind of shows you where it sits on campus, right? So so you can kind of find out where that is. So they're a good question. Does that date range include retakes? No. So retakes, I'll give you a few days on the other end. Everything happens so fast in the summer, but we'll get you your grades. I'll get you your grades. Some of you are going to know that you failed the test, so in that case, just start studying already. Just start studying. Get the things you missed. Just start studying those, so you're going to be even more ready for the retake. But once we get back that next week after the test, I'll have the testing center all set up to take your retake appointments. You'll have a few days over which that you can get that retake done, and then we'll go from there. Okay, so that's option number 1, is you make an appointment in the testing center, you go in there, you take your exam, everything's good to go. I know some of you are not able to do that, so on a week from today, our Zoom meeting will actually just be the exam. Some of you will be taking the exam in class. And then, so there's a couple things going on here. One, we're technically not supposed to force students to turn their cameras on, but that obviously makes for some difficulties. So what will happen is about 15 minutes before class, a week from now, I'll make this version of the test, because there's more than one version of the test, because I can't, once I post the version of the test for you here, I can't also use it for other students, because then they would know what's on it. Anyway, so there's a few different versions of the test depending on which way you take it. Okay. So a week from today, I will post the exam like 15 minutes before class. I'll post the exam. That gives you a little bit of time to like print it and everything. So make sure your printer has ink. Make sure your printer has paper. Otherwise, you're not going to be able to print the thing, right? Or make sure that you're somewhere where you could print it. You could go to school, print it, take it, turn it in, whatever you need to do. If you have your camera on during the exam, then I'll make a note of that, because I'll be making notes while I'm sort of proctoring visually through Zoom. Make sure if you're willing to turn your camera on in a way that I can monitor you and I can be convinced that you're not doing anything nefarious or that you shouldn't be during the exam, I'll make note of that, and then you can take the retake as well. So people who show up to the VC testing center and take the test, you can take the retake. People who take the test during Zoom and leave the camera on, you can take the retake. Okay, I know some people don't want to show themselves on camera. That's fine. I'm not going to force anybody to. We're actually not really supposed to force anyone to turn their cameras on as well. But as you can imagine, that leads to lots of other issues. In fact, that's why some people, not everyone, but some people prefer the online classes, is because it's harder to monitor what's going on. You can take the test with your Zoom camera off, but in that case, you will not be taking a retake. Okay. For the people that take the test during class, you have to get that thing scanned to me quickly. In fact, what I'll do when you're done is you'll just kind of show me on screen your paper. You show me the work you've done, and then you're going to scan it and get it sent to me as soon as you can. If it takes you like a day to scan it, that's going to be a problem, because I don't know what happened to your test in between. That's why you're kind of showing me the papers, so I can look and go, did this person do anything weird? Like, did they keep working on it afterwards or anything? So anyways, then you have to post it. You have to scan it and then post it to the assignment, and then I'll grade it from there. Okay, so you have to, if you're going to do it from home, you have to be able to print within 15 minutes. Like I say, I'll post it about 15 minutes before class, and then you're going to have to be able to, in about 15 minutes, get it sent to me. Oh yeah, so good question. Do you just email me the file? Don't email it to me. I get so many emails that it's like impossible for me to keep my email organized. It just really becomes a huge mess. So what I will do is in here, where I have this listed, you will post your exam here into Canvas. So once you have that file, that PDF file, however you make that, you're going to upload it into this exam where it says exam 1, you're going to upload it into here. So I haven't gone through and edited like the number of points and stuff yet, but you'll just submit right here into Canvas. So for those of you who are watching, right here where it says exam 1, once chapter 3 is all published, in fact I think you can see this right now, you'll go in here and publish it. You'll submit it right in there. Okay. And then yeah, so you can decide if you want to have camera off, you just don't get the retake. If you want to do camera on so I can verify that you're actually doing the test properly, then I'm fine with the retake. This is the only test that has a retake. At the end of the semester, the final's not going to have a retake. There's just no time. Like, everything just happens so fast. But I do want to make sure that students have a chance to redo this first exam. If you do poorly, you can go back and improve that grade and still have a chance to pass the class, okay? Right, so if there's any questions about that, let me know. Oh, right, so Chapter 2 we're going to talk about here in a little bit. We'll finish talking about it. I have 2 upcoming videos for Chapter 2. I recorded the videos and I got all my editing software updated. I haven't edited videos for a couple years, so but I updated all the video software and editing software and that kind of stuff. I got the videos recorded, but I was not able to edit and update them. That's actually what my afternoon's going to be about. After I go pick up my car again, I got a little sidelined because I got car issues. Took up some time yesterday that I wasn't quite expecting. So I have to go pick up my car after class today, and then I'm going to come home, I'm going to edit those videos, and I'm going to post them. So I have a video on circles coming up and a video on transformations. Now there's already videos in there, so you don't have to wait for the videos that I'm posting. But if you wanted, you could go back later today, hopefully later today. Hopefully I get them up by, the evening. And then you can watch those videos if you want. So there's 2 more coming for chapter 2, and then I've got, let's see, I made an outline of all the videos I have to make for the rest of the course. I've got 1, 2, 3, 4 more videos that I have to make for chapter 3, so I'll be kind of busy this weekend. There'll be some other videos in here, so you'll see I'll start to release these chapter 3 sections one by one as I get the videos up. So there'll be some of the videos will be me, some of the videos will be other people getting all that stuff done. Chapter 3 is a bit of a step up, so it's difficult. Some of it's difficult. The first section's not bad, and really the second one's not terrible, but it gets a little heavy in the middle to the end of the chapter, so just sort of be prepare for that, plan for that, for it to be a little trickier. But I will get videos up, so we'll see all that, and then we'll continue with stuff on the other end of the exam. Great question here. On exam day, do we join YouTube Live or Zoom? You're going to join Zoom, and here's one of the reasons why. Is like the timing of this actually all worked out kind of perfectly. I will be out of town, so I won't even have access to my streaming setup. I won't have OBS streaming software, and I won't have like all my settings right for streaming. So the YouTube video will not be available that day. So when you show up to take the test, you have to do it in Zoom. So make sure you're in Zoom. If you're not in Zoom, in fact, I should put that in there. If you're not in Zoom, then it's not gonna, it won't count, right? Yeah, you have to be in Zoom in one way or another. Even if your camera's off, you got to be in Zoom. So let me put that in here just so there's no mistake, and that's a great question. I guess it's kind of in here stating that the Zoom camera's on or off. Taking class during class in Zoom, and then let's put that down here. In Zoom. So I guess it was kind of in there, but it's a good question just to clarify so that everyone's on the same page and no one's confused about this, because you don't want to mess this up. You have some options, but they're all going to take a little bit of planning for you to get stuff done right. So yeah, so you'll go to Zoom on that day, and then you'll decide if you want to be in this camera on group or you want to be in the camera off group. I'm not going to hold it against you if you want to have your camera off. Everyone has reasons why they want, different privacy for stuff. It's just you're going to decide which of those options that you want. Do you care about taking a retake? Is the retake not important to you? It's kind of up to you. So for taking the test in the VC Testing Center, I've got the dates down here. You have from the 5th to the 11th to do that, whenever that works out for you. If you're going to do it in class, it has to be the 7th. Okay, that's the only date you'll have to take it in remotely is the 7th. If you want to take it in person, schedule your stuff between the 5th and the 11th. Don't wait till the last day. Sometimes students have a little bit, it takes a couple tries for them to get an appointment made. So if you wait until the day of the 11th and you're trying to make an appointment, it's not going to happen. So whatever date you're going to reserve for taking the test, I would do it now. Just get on it right now. As certain times fill up, then they're not available. They only have a certain few times for each person. So make sure that you get that appointment taken care of. There's another one of those things, like don't procrastinate, right? The people who don't procrastinate, this is going to go fine for them. The people who wait till the last minute, it's going to be a problem. So just be aware, if you have any questions about tests, get a hold of me, because I don't want anyone to not be able to take the test. So make sure that you have a plan for how you're going to do this and that it is working for you, okay? Good question. So a question here, if we take the test on the 11th, do we still have to attend class on the 7th? No. But make sure you have your appointment, because you don't want to end up not taking any test, right? You want to make sure you take at least one of these versions of the exam. Right, as you go through and do that. So, yeah, good question. So if you're taking it on the 11th, you do not have to show up to class on the 7th. You won't be marked down for like not attending. I'll just assume that you're going to take it online. Yeah, you can make the appointment via email. So if you click that link that I gave you for the testing center, that's probably the best way. Get a hold of them. Oh, here's what they need from you when you contact them. They need my name, my class, your name, and your 900 number for the your school ID. It's in Canvas. It's also in your VC portal, that 900 number. You can go in there and just figure out what that 900 number is, but they need that in order to make the appointment. So make sure, that's the easiest way. If you give them all the information, you're more likely to get your appointment. So tell them my name, this class name, Math V04 College Algebra, Exam 1, your name, and your school 900 number, and then give them an idea of when you would like to take the test. Look at their hours. Like if you give them a time outside these hours, they're just going to think you're ridiculous, because that doesn't make any sense, right? But if you say, oh, I want to take it on this date, at 2 o'clock, then they'll try to make that appointment for you. And if it's busy, then, or if it's full, they'll go, oh, can you take it at 2:30 or something? And you go, yeah, that's fine. So you can do whatever you need to do. But yeah, that's a legitimate way of setting up the appointment. Okay? Any other questions about how that's going to work? We're all good with that? Okay. Yeah, great questions. Great questions. And a lot of people are doing the homework, so that's great. Keep all that stuff up, everybody, okay? Oh, and we only had about 9 people take that student survey. This is how we make this, feedback from students is one way that we make decisions for the future about the classes that we offer. So really would be helpful if people could get in there. Remember, it's going to count as a homework assignment. So once I'm all done, I don't think it's done yet, right? It's still, yeah, you have till the 5th. So please get that done, because that would be valuable information for us to make sure we're offering the class as well. Let's see, let me check my page here. Yeah, okay. So unless there's questions, let's move ahead into things and see what we're looking at. So first, let's take a look at a couple questions that I got. Okay, let's make this smaller here. Okay, so these are some homework questions that I was asked about, and we'll go over them. Use the graph to determine A, the function's domain, B, the function's range, C, the x-intercepts, if any, D, the y-intercept, if there is one, and E, the following function values. Okay, so remember, the domain is the x values. So what you do is you look at the x-axis, and you just kind of scan and you figure out, can I put any x value I want into this function? The domain are the values that feed into the function. Remember that image with the machine, and you had inputs going into the machine and things coming out? The x's are the things going in. That's the domain. So it looks to me like if we scanned this picture out of this graph, we would see it going in both directions forever. So what that means is any x value I pick, I can put into this function. So that's why the domain for this is -infinity to infinity. It's any number. We can stick any real number we want into this function and we'll get something out. So you look at the x-axis and you look at those x values and go, which of those x values have points on the function, right? So you kind of think about like, okay, what if there was a light up here shining down on the x-axis? Would any light get through, or would it like all hit the, would this whole function be in the shade or whatever? So you're just kind of matching up the x-axis. with your graph and trying to figure out, like, okay, where are all these x values accounted for? And the answer is yes. It's negative infinity to infinity. What we sometimes call all real numbers. Okay. Now the range is the y values. That's the things that were coming out of that picture, the outputs from that machine picture of the functions. So our y values, that's our y-axis right here, right? So what you do is you look at the y-axis and you go, which y values correspond to points on the graph? Well, down here I can look, -3, oh, there's a point with a y value of -3. What about -7? There's a y value with a point of -7 over there. What about 2? Oh, there's no y values up here. And it doesn't look like there's ever going to be, right? So what about 0? No y values up here, no points up here. -1, no. -2, oh yeah, look, there's a whole bunch of points here whose y value is -2. So when you look for the domain, you're looking at the x-axis and where that corresponds to the function. When you're doing the range, you're looking at the y-axis and figuring out where that corresponds to your function. So in this case, the y values go from -infinity up to -2. That's the biggest y value that we get. The biggest output from a function that's possible from this function is -2. And so that's why our answer is, I'm trying to get out of the way here, -infinity to -2. Okay? All right, so that's that one. Enter the x-intercepts. Okay, this one doesn't have any x-intercepts because an x-intercept would be where the graph crosses the x-axis. It never does, so there is no x-intercept. So that would be that one. There's no x-intercept. Okay. Enter the y-intercept. So then we ask, where does our graph cross the y-axis? Looks like that happens right here because here's the y-axis, here's the graph, and they cross right here. It looks like at 0, -4. So the y-intercept is -4. Okay. And it says, what are the values of this function? Okay, so it's giving us f of a number. That means f of an x value. So we're taking an x value and we're plugging it into our function. So let's see, if I take -5 here and plug it into my function, so I find -5 on the x's. I go, where is a point that has -5 as an x? Oh, it's right here. The y value is -2. So this will be -2. Okay, and then f of 1. Okay, so I find 1, and I go, well, that has a y value of -5. And then we're done. So we finished that question. Okay? Let's look at this one. Oh, here's one about the difference quotient. Oh, you'll have a difference quotient problem on the test, and it's going to be a quadratic. So make sure that you can do the difference quotient of a quadratic. And make sure you write it out. Sometimes I get people that are like, oh, I took calculus in high school, so I just know the shortcut. Now you got to like show the work, right? Show the work for the difference quotient. That's kind of why we're learning it. So you can do that. So here's one of those fill-in-the-blank answers. The expression f of x plus h minus f of x over h, where h is not equal to 0, is called the difference quotient, okay, of the function f. We find this expression by replacing x with x plus h. That's what the f of x becomes x plus h each time x appears in the function's equation. Then we subtract f of x, right? So f of x plus h minus f of x. After simplifying, we factor from the numerator and divide out identical common factors. Whoops, we factor, let's see, what are they trying to say? After simplifying, we factor, I think h is, it's a little convoluted, but I believe what they're getting at is that we're going to factor an h out from the numerator and divide out identical factors of h in the numerator and denominator. Is that what they were getting at? Yeah, okay. Okay, so it's just that it's just they make it a little bit overly confusing here. Maybe I should have even just not included this one because I know people get bogged down in the language. But make sure you can calculate a difference quotient, okay? Okay, use the graph to determine open intervals on which the function is increasing, if any. So this function is never increasing, right? Remember, increasing, that's that bank account you want, or the line's shooting upwards, that's representing an increasing bank account. This one never does that. Okay. Open intervals on which the function is decreasing. Okay. If any. And then open intervals where it's constant. Remember, constant means it's level, like a like if your bank account just has $100 in it and you never spend any money, it's just a flat line. That's what we're looking at right here. So, okay, good. There is no interval on which the function is increasing. That's correct. Below, select the correct choice below. If necessary, fill in the box. The function is decreasing in the interval from 1 to infinity. That is true. Oh, someone just, I got the answer backwards. It's decreasing right here, this part of the line, that's a decreasing function. Think of your bank account. That would mean you're spending money or someone's taking money out of your account and the value's going down. All right, think of it like a stock or an investment. It's decreasing, right? Your value is decreasing. So that's happening from x equals 1. That's, you go, oh, right at x equals 1 right here. That's where the behavior is changing. So from 1 to infinity, the function is decreasing. Okay, so we'll say, yeah, that's decreasing, continue. And then select the function is constant. Well, it's constant over here up to 1, but from negative infinity. So this one's gonna go negative infinity. Oops, thinking of the wrong piece of software here. They make me click the button. It's nice when they let you use shortcuts. Negative infinity to 1 should be our open interval. Yeah. Okay. So that's what they wanted us to do. It just takes a little practice. And then let's take a look here. So this one's a little more in depth. So a student sent me this. Solve the equation with rational exponents. And so far everyone's been really good. When you send me a question from the homework, there's that little choice where it says ask your professor. And when you do that, it sends it to me in a mode like this where I can just directly see the problem. Also, this okay, this works. Student sent me a screenshot or a picture or something of the screen. That totally works too, because when I look at it, I know exactly, I can see exactly what the question is about. Okay, what I sometimes get from students, which doesn't work, is like they'll say, oh, can you help me with the homework problem? And I go, great, which one do you want to look at? And they're like, well, it's like that one that had an equal sign in it, and then you were supposed to like talk about a function or something. Like, I'm not going to have any idea what you're talking about, right? So please, if you're going to send it to me, and everyone's been really great about this, just keep it up. Either use the Ask Your Professor feature inside of my math lab. I think it's over on the right, maybe. Or do like this, where you send me a picture of it, because then when I see this, I go, yes, I know what you're talking about. Otherwise, like when students try to recreate the problem from memory, it's like I literally don't know what you're describing. So yeah, keep that up. Okay, so this is good. This is helpful. X minus 5 to the 2/3 equals 81. Okay, let's solve that. So how are we going to do that? So x minus 5 to the 2/3. Equals, what was it, 81 or something? Yeah, 81 equals 81. Okay, so like a lot of things, you know, like this even more so than algebra, again, everyone's work can look a little different. So if you see me do something and go, oh, I solved it, but I did it a couple steps differently, doesn't mean your way's wrong. Okay, there's just different ways of, everyone's brain's a little different, and you sort of organize work differently and work it through differently. So that's fine. So looking at this, what we have is x minus 5 to the 2/3 equaling 81. So what we're going to do here is we're going to raise everything to the 3/2. So this is basically going to become this. Raised to the 3/2. And then we're going to raise this on the left to the 3/2 as well. Let it just update. There we go. Okay, so see, I'm raising both sides of the equation to the 3/2. Now, why am I doing this? Because when we raise 2/3 to the 3/2, remember that's the exponent rule that says multiply those exponents together. Well, what do you get when you multiply 2/3 times 3/2? You get 6/6, which is 1, which means we've simplified this complicated fraction, fractional exponent. You might go, no, you didn't. You just moved it to the other side because now we have 81 to the 3/2. Yeah, but that's easier to deal with than a variable. Okay, so on the left, this is going to simplify to be, on the left, we're going to get x minus 5. That was the whole reason we did it. And then if you remember how your rational exponents work, the denominator is the index of the root, and the numerator is the power that you're raising everything to. Okay, so for instance, so 81 to the 3/2 should be, you have two ways to do this if you look up the formula. You can either think of this as the square root of 81 cubed, except I don't really want to cube 81. That seems like more work than I would need to do. So the other way you can do that, instead of taking the square root of 81 cubed, you can take the square root of 81, figure out what that is, and then cube it, right? This is a case where the operations work both ways. So I'm going to do the square root of 81, and then we're going to, slash, and then we're going to raise all that to the third, and I don't know what 9 to the third is. Let's look over here. Whatever 81 times 3 is, right? 729. So the square root of 81 is 9, and apparently 9 cubed is 729. It's not one I know by heart. So then we get x minus 5 equals 729. And then from here, this last step is easy. You're just going to add 5 to both sides, right? So adding 5 to both sides is going to give me x equals 734. And that should be our answer here. Yeah, that makes sense. That makes sense. Okay. So yeah, that was good. Good. Keep sending the problems, and I'll keep going over them. So that's good. So we can fill in the gaps when people are having trouble. Okay. All right. Then, if there's no more questions, let's move ahead. Let's see. I can go ahead and delete these now and clean things up a little bit. Okay. Go ahead and, I don't remember if I'm going to use that yet, but let's see. Okay, so now let's get into finishing up chapter 2. So like I say, I have 2 more videos that are coming. You don't have to wait for the videos. In fact, they're probably just extraneous, but there's 2 videos that I put together. I'll put them up later today. One is about transformations. So I don't remember if I talked about transformations at all last time, because now I can't remember if it was in the video I talked about them or if it was at all during class. But I highly recommend you use Desmos in this class. It is a great graphing utility. It's very easy to use. It's highly accurate. It looks good. It's very, very convenient. So I've just opened Desmos, have it available, and then you can graph things. What you don't want to do is use it to do your work for you. You want to use it as a tool to help you learn this material. So, it used to be more, like graphing 40 years ago was really important because it was rare that you would find something that could graph mathematics for you, 40 years ago. You couldn't even find computers in most places, right? Now you just take out your phone and you have it graph a circle for you. So The reason that we put so much emphasis in this class on graphing those, because when you go through and graph things by hand, it helps you learn all these tools that we're talking about all along the way that we're going to be talking about. The division and the rational root theorem and multiplicities and all these kind of things. You have to really work through the details of some of these problems in order to really understand what those things are about. However, in real life, most of the time that you have to graph something, you're going to grab a graphing utility. I mean, think about it. If you're watching a presentation and someone puts up a computer-made graph and then you've got like a hand-drawn graph, but, you know, it's just not going to look as professional. So when doing college algebra and calculus and stuff, you have to be able to do both. You want to be able to use tools to do the graphing for you, but if someone took that, like here's how you should kind of gauge yourself. If you were working on something and someone came along and took Desmos away from you, could you still do the problems? Could you still do the work? Sure, it would take you longer and it would be annoying and tedious, but could you still do it? If the answer is yes, then you're fine to use Desmos and use a graphing utility. If the answer is no, then what it means is you're building a house of cards. You're learning some steps, but you don't really know what's going on, and that is usually followed within a few weeks or months of a student going like, I'm lost, I don't know how to do stuff anymore. But it's because you started building that really bad foundational mathematics. It's like if you tried to build a house and you're like, let's only put half the foundation in, but we'll build the whole house. Guess what? It's going to be followed by a bunch of problems, right? So it's the same thing here. Use Desmos, but I encourage you to use it responsibly. Use it as a way to help you learn, not as a way to try to like shortcut homework for you and stuff. With that said, very, very helpful. We're gonna lots of graphing that we need to analyze throughout this semester. So, transformations is what we're looking at. So the video will be up hopefully in a few hours where I go through. There's a few things that we need to know here. One is a family of graphs. So let me grab that. Oh, am I right on the right page already? Looks like I am. Okay, so close that and go. Okay, so the first thing that we have is what are called the families of graphs. So these are just representatives. There's like some major families. That just means a certain type of function. So when I say a family, it just means like one type of graph that are going to come up a lot. And you want to be able to recognize these. So obviously a line, I think most of you could recognize a line. If I gave you a graph of a line and said, what is this? Hopefully you would be able to go, a line? Yeah, that's right, it's a line. Okay, but you want to be able to recognize all these different graphs because we have different tools that we apply to these different graphs. So that's kind of step one in analyzing things is like, well, what type of function are you dealing with, right? If you're dealing with a quadratic, you have a certain set of tools. If you're dealing with a square root function, you have another set of tools. So you can't really get started till you know what you're doing. So you want to be able to recognize these. This is a constant function, right? We've talked about that already. It just means things are unchanging. That's why we call it constant. Your bank account's not going up, it's not going down, it's just constant the whole time. Okay? And that's just given by the line y equals whatever. Y equals 100 because you have $100 in your account and it's not changing. Okay? The identity function y equals x, extremely important function. It comes up in all sorts of theoretical mathematics. Y equals x, that function is like a very special function, and it's given away by the name identity. We don't need to get into like all the ways in which this is like amazingly cool function, but it has some, I don't want to say magical properties, but it has some really neat properties. So you want to be familiar with that line y equals x. You'd be surprised as you continue through mathematics how you're working on something and then all of a sudden someone's talking about like, oh, well, if we combine this with the line y equals x, then this cool thing happens. And it just comes up a lot. Okay, so you want to be able to recognize that. Anytime you have a function with this hard V, right, it's like a sharp V shape, you're probably talking about some type of absolute value function, especially for this course. The things we're dealing with, if you see a V shape, like where it's got a sharp corner in it, then we're probably talking about an absolute value function. So when you see a V, whether it's skinny or wide or whatever, if you see a V, it's some type of absolute value. If you see a U shape, that's what we call a parabola, and that is a second degree quadratic. So it's a second degree polynomial. Okay? You've got versions of your square root functions that look kind of like this. You've got your x cubed function, and then your cube root function. Almost all of the functions, with the exception of rational functions, which you'll learn about later in the chapter, but many of the functions that we deal with are going to fall in one of these families here. And the quicker you get at identifying, oh, that's an absolute value, so I'm going to use my absolute value tools. Oh, that's a quadratic. Well, I know how to deal with quadratics. Then it helps you narrow in on how to attack that problem, okay? So that's the first part of this section, is just getting to where you can recognize the families. The second one is understanding transformations, because right here, this is our representative for parabolas. Well, what about a parabola that does this? That's a different parabola, right? But it's still a parabola. So then what we want to know is, how do I get from this red base parabola, that's the real easy y equals x squared one, how do I get to this version where it's like, it's a little skinnier? Look, we could even do this. We could even flip it upside down if we wanted. All right, okay, I've got a skinnier graph. It's flipped upside down, and it's moved horizontally and vertically. Well, each of those things I just described comes about because of what we call a transformation. Now, what you want to do is look at, where is your transformation occurring? This is the key. These numbers that I put in here, where do they occur? Are they occurring with the x before the main operation is taken? Like, see how I'm subtracting 2 from the x before I do the squaring? That's going to have one type of effect. See how at the very end of the problem I'm just subtracting off 7? That's going to have a different type of effect. This 3 right here, where I'm multiplying the operation that the problem is about, in this case squaring, that's going to have a different type of effect. This negative in front, that's going to change it as well. So what you want to be able to do is recognize what those changes do, because here's the good news. Once you learn transformations for one type of function, it's the same for the other types of function. Okay, so once you learn transformations for quadratics, it's going to affect absolute value functions the same way. And it's going to affect square root functions the same way. It does the same thing, right? So let me give you an example here. Let's close this one down, and we'll go y equals a x minus h squared plus k. Okay, so here's one thing I want you to see. See how it's saying, do you want to add sliders for these? Because it says, I don't know what a, h, and k's are. I know what x's are, and I know what y's are, but what are a, h, and k? It's saying, are you trying to use those as parameters? And in fact, yes, I am trying to use them as parameters. So let's add all of those. And so now what that means is I can change this k value by just changing the k slider right here. See how it's changing my k value? So this expression, it's now putting k in here, and it's changing it in that way. Then the nice thing about this is that you can play around. I encourage you to do exactly what I'm doing right now. Go into Desmos, play around with these values, and just see how it changes. It's so dry reading the book where it says, okay, if you change this, then that's a vertical transformation. But if you're in here in Desmos doing the changes by hand yourself, I find students learn faster, and also it's a little more interesting than just looking in the book, right? So see how you can look at it. So the k is that last value on the very end of the problem, and if you look, it looks like that just translates everything up and down. So that is where a vertical translation comes from. Okay, so this thing on the end, hanging off the end of the problem, when we change that, just moves the graph up and down. Okay. Let's see if we can go. There we go. All right, what about my h? So this value that's in here with the x before we square it, okay, it looks like that moves things left and right. So that's a horizontal. That's how we translate things horizontally. Okay. All right, well, what about this a value up front? What if it looks like if I make a bigger, it squeezes that parabola down skinny. And if I bring it out, it gets wider, kind of a squat parabola. And then if I go negative, it flips the thing upside down. So then you start to learn, if there's a negative in front, it's a flipped upside down function, right? And you start to put all these pieces together, right? And then you can move them around that way. So that's what I encourage you to do in this section. Just pull up Desmos, play around with this stuff. It's going to help you very quickly figure out what those different transformations do, right? To the point where you're going to be able to do the following. When we look at these two graphs, like, because you'll have a problem on this test where you have to explain what the transformations are doing. So here you'd go, okay, well, so it looks like, so looking at this x minus 2 means that my graph is being shifted horizontally it's being shifted horizontally 2 units. Now be specific on the test. When I have you do this, I see a full range where students go from not enough information up until like the exact amount right of information. Basically give it all. So sometimes, you know, students aren't specific where they'll say, oh, it shifted horizontally. Okay, shifted horizontally, how many units? Which direction? Right? So give all that information. So the proper way to state this on the test would be, okay, if I start with x squared and I want to end up with the blue graph, then what this is going to do, this is going to be a horizontal shift 2 units to the right, 7 units vertically down. It's flipped upside down because of the negative, and it's made narrower by a factor of 3. See how everything I just gave was very specific? If you just say, oh, it's shifted horizontally, I don't really know if you know what you're talking about. But if you say, oh, it's shifted horizontally 2 units to the right, then I kind of have to believe that you know what you're talking about, right? Because you gave the exact right description. And then if you say, oh, this is shifted vertically 7 units down, well, it seems like you know what you're talking about then, right? So make sure that you're specific and you give those details. And that's one of the reasons that I'm going to give out the solutions as well, even though I'm giving them out just shortly before the test. But I'm giving them out so that you can look at the way that I give you the solutions in the solutions test, to the practice test. That's kind of what I'm looking for, right? So if you see that I'm being very, like, if you do the problem and then you look at my problem, my answer is very different than yours, even if you go, well, they both have the same number in them, it doesn't mean they're going to get the same number of points, right? So so you want to look that over. Look over my solutions and go, oh, he wants me to be really specific here. Yeah, probably. So pay attention to that. So just play around with these a little bit, right? Get in here, play around with Desmos. I find that's the fastest way to really learn these transformations. Okay, so that's 2.5. 2.6 then is about composition of functions. And composition of functions is a little bit more complicated, but it's not too bad. It's one of those things where, like, at first there's one or two things you have to be careful about. Once you get that done, you're good to go. So let's see, I want to go to page 308. Okay, and here's the reason why. Here, this picture explains what composition of functions is all about. Okay, remember the other day when we talked about functions and I showed that and I referenced it today. There's that picture of the machine. They call it a function machine, where you're putting an input in. There's like some gears and belts and pulleys, and then out comes an output. Well, we have 2 of those right now, but we have to be careful because, you know, depending on, you know, what kind of classes you've taken, you may have learned about things being in series versus parallel. It's kind of 2 ways you could set up functions, right? Do we get to do them in series or do we do them in parallel? Well, in this case, you have to be careful. They're not in parallel, they're in series, because what a composition of functions means is that you take an input, just like we always do. So this first half should look like normal. We take an x, I put it into a function g. The thing that comes out, we call it g of x. So g of x is the output from the first function. It is the y value from the first function. And then what do we do in a composition? We take the output from that first function and we use it as the input into the second function. Okay. So I don't really have time to show you, but if we were in class, if we had more time, I'd go through and we'd prove that the order matters. If you do them in the wrong order, most of the time you will get the wrong answer. Every once in a while, especially when you have inverses, if you reverse the order of the composition, you're still going to get the same thing. But most of the time, almost always, you're going to get a different value. So you have to make sure that you're putting it through the right function first, and then whatever comes out, you're putting it through the next function. Okay? And we just use this, like, this is kind of an old school notation. It's still used, but I find it weird. You know, we're better off just using this one. So I kind of stick to using the f of g of x because it's real easy to keep track of the order. You start with an x, it's getting plugged into g. Whatever comes out of g is g of x, that gets plugged into f. So it's really saying, take an x, plug it into g. Whatever y value comes out of g, plug that into f. That's all composition is. But composition is hugely important. Those of you going on to calculus, you'll see either calculus, either the applied calculus or the engineering calculus, you're going to see composition is a big deal. Okay, and so we want to be comfortable dealing with compositions, breaking them down, building them up, doing things with them. It's really important. So let's kind of do one. Basically, all you're doing is you're sticking one function into the other one. It's actually not nearly as complicated as it kind of seems. But let's take a look. I don't want to make this extra big because I'm going to run out of room. So let's do this. Yeah. So we've got f of x equals x squared plus 1, and g of x equals x plus 3. And I want to know what f of g of x would be. So that's our composition. So you work from the inside out. What does f of g of x mean? Well, that means I'm taking x, I plug it into g, and I plug that into f. So basically, we have what g of x is right here, and it's x plus 3. So we're going to plug that into f. So it becomes f of x plus 3. Okay, but what is f of x plus 3? Well, f says that whatever you put into it, you're going to square and add 1. So this becomes x plus 3 squared plus 1. So we're just applying the function f to the function g. That's all that's happening. And then I'm going to run out of room, so I'll write this on the next line. This is going to become what? X squared plus 6x plus 9 plus 1. Right? The x squared plus 6x plus 9 is this x plus 3 squared part. Remember, you can't just square the x and you can't just square the 3. You have to FOIL them. Write it out as two separate factors. FOIL, here, FOIL. You get x squared plus 6x plus 9, right? Because the 6x is, you've got a 3x for your outer terms and you've got a 3x for your inner terms. So when you add them together, you get 6x plus 9. And then the plus 1 on the end is this plus 1 right here. And then, of course, we would go ahead and simplify that to x squared plus 6x plus 10. And then we fully simplified that answer. Now, you want to be careful with these compositions because you can do them algebraically like we're doing, and then you also will have the visual versions of them. You can do compositions by looking at the graphs, which is also a thing you want to kind of pay attention to. But that's all there is with composition, right? I want to make sure I'm leaving time for stuff. So, but if we switch it around and do g of f of x, we will get a different answer because it's a different ordering of those. So you have to be careful with the order. Okay. So that's really all there is to the compositions. And notice you could do it by hand. You can take you'll have problems where you have to take an actual value and plug it in. So like they might say, what is f of g of 3? And in that case, you would take a 3 and plug it into G, see what comes out, plug that into F. So it's not any harder, it's just you're doing it with, in fact, it's easier, but you're doing it with numbers rather than algebraic expressions. Now, you're going to have a problem like, or I sometimes put versions of the following on the test, so I want to make sure that students know how to do this because they definitely get confused on it. Okay, this is on page 313 in your book, in case you want to look that up or anything. But I'm going to look here at this one. Let's see if I can make that bigger for now. Whoops. Oh yeah, that's what I wanted. Let's go ahead and make it big. Okay. Let's close that. So we're looking at this thing, and it says we want to know, like say find f plus g of -3. Okay, so how would that work? Well, it turns out that f plus g of -3 is f of -3 plus g of -3. So that might seem confusing. You're like, wait, what's f of -3? Remember, that's just your output from plugging -3 into f. And g of -3 is your output, your y value, from plugging -3 into g. Well, we can get that easily by looking at the graph. I just have to look at -3 and go, which one's f? The blue one's f and the red one's g. Okay, so f of -3, that's a y value of 4. G of -3, that's a y value of 1. So if I add those together, I get 4, right? 1 plus, oh wait, what was it, 4? Oh, 1 plus 4 would be 5. So number 83 here, that answer would be 5. So that's all you have to do for each of these. Now it gets slightly more complicated when we do the composition version, because you have to remember you're taking your first y value and you're using that as input into the second function, right? So here they want to know f of g of -1. So that's f of g of -1, so you can think of it in the sort of the parentheses version that we're doing. You're first going to take g of -1. So I first find -1 on the x-axis, that's right here. I'm going to plug that into g, and it looks like I get -3 down here. Okay, so my output, so I take -1, I plug that into g. The thing that comes out is -3. Now I'm going to take that -3 and plug it into f. So I go -3 being plugged into f is now +1. So this 91 right here, the answer would be 1. Okay, let's try it with f of g of 1. So I'm going to do g of 1. So that means I have an output of 3. So now I'm going to take my 3 and plug it into f. So I go over here to my 3 on my x. For f, that comes out to 5. So 92 should be 5. Okay. So there's a problem like that on the test. So just make sure you visually, just always think in terms of x's and y's. I know it's kind of new, people getting used to function notation, and then on top of that, we just threw this new weird little circle composition notation at you. But if you just always like break it down into that picture that we looked at, like if you can do this part in your brain, where did it go? Oh, I gotta shrink everything down. Like if you can think about it this way with these pictures, then you'll be okay, because like that's kind of tends to be how I keep everything straight when I'm doing those complicated problems. It's like, okay, I've got a value, I'm plugging it into a function f. Now my output, I use that to plug into the new or I guess that was g. Then I use that to plug into the new function f. So just if you can think about it as x and y's coming in and out of functions, you can usually keep track of it a little bit better. Okay. So that is composition of functions, and there's videos up for that. Then we get into 2.7, which is inverses, which is part of the reason we talk about composition. And there's a, let's see, was there one other? No, we did the thing I was going to talk about. Okay, good. Okay, so let's find on page 318. Okay, finding the inverse of a function. So here's how you do it. So there's a few things you need to know. So make sure you read through the book and watch the videos. There is some geometry that gets carried over because of how, like, the meaning of an inverse. So in other words, you can, if you have two inverses graphed on a function, you'll be able to tell they're inverses of each other because they have a geometric relationship. Which sort of looks right when it looks right, and when it looks wrong, your brain goes, something's not right with this picture, and then you know that those are not inverses. But that carries over algebraically. So basically, let's go ahead and talk about it here. Let's get rid of all of these. Remember that line y equals x I talked about? Well, here it comes again already. So if you have an inverse, it is going to reflect across the line y equals x. So let's say I've got y equals x cubed. So that's a function that I've got, okay? And I want to come up with its inverse. Well, I'm jumping ahead because we haven't learned how to do this yet, but so I'm cheating a little bit. The inverse of that is x to the 1/3. Okay. Do you see how there's a symmetric relationship here? You see how if you take the green function here and you reflect it across the line y equals x, across the blue line, you get the purple line? Like if we printed this out, if everyone printed this page and we folded our paper along that line y equals x, the green and the purple graphs would line up right on top of each other. That's what you expect to happen with inverse functions, right? So let's just say I made a mistake in my algebra. Let's say I screwed up and instead of getting x cubed plus x to the 1/3, I got x to the 1/3 plus 1. Oh, that doesn't look right anymore. Your brain instantly knows, right? When you look at that, your brain's like, that symmetry is not like it's supposed to be. So your brain can immediately tell, like, yeah, something's wrong. So this is a nice, quick way. If you think you found the inverse for something, like this I would do on a test. If you think you found the inverse for something, graph them and see if they have that proper behavior. Oh, by the way, you can have a calculator for the test. So graphing calculator is fine. It cannot be your phone, right? Under no circumstances can you have a phone during the test, but you can have a graphing calculator, TI-84 calculator, whatever you want. You don't have to have one, but you are welcome to have one. I think I told them that in the testing center. I said calculators as long as it's not a phone. Okay, so you can tell pretty quickly they're, when they're not right, and then when it looks right, your brain just goes, oh yeah, that's totally symmetric. I know that that's working correctly. Okay, so that's geometrically for the inverses, but how do you find them algebraically? So what I will tell you is generally on tests, I make you find the inverse of a rational function. So like example 4 on page 319, that's along the lines of what you could expect to get on the test, right? I find that it's challenging enough, but without being like crazy challenging. It's not like super hard, but if you can find the inverse of a rational function, then I'm convinced that you can find the inverse of most functions. Okay, like because lines are super easy to find the inverse for. Some quadratics don't have inverses. That's another quick way we can tell if something even has an inverse, is the horizontal line test. So because of this relationship with remember we talked about the vertical line test last time? Well, if you take a vertical line and you reflect it across the line y equals x, you get a horizontal line. So the vertical line test, when reflected, becomes the horizontal line test. So we use the vertical line test to tell if something's a function. We use the horizontal line test to tell if it's going to have an inverse. Okay, so here, horizontal line. So this looks like it fails the horizontal line test because our graph is hitting the line twice at one time. That means that y equals x squared does not have an inverse. Why is that? Well, look what happens when we come up with what the inverse would be, which is x equals y squared. Oh, now it's not a function because it fails the vertical line test. So that's why the vertical line test and horizontal line tests are related, because you get one from translating across that line y equals x. So, but if we had something like the following, this has an inverse, right? This has an inverse. Look, oops. It passes that horizontal line test. You might go, well, what about right there? Doesn't it flatten out right there? Nah, it kind of flattens out, but it doesn't get flat. Like there's never a point where it's actually horizontal. So we're fine, right? And when you, you graph it, you get that. So that's how you get the inverse. So that's how they look graphically, but you go, okay, but what about when I'm trying to algebraically find the inverse? You follow these 4 steps. Of the 4 steps, 3 of them are ridiculously easy. They like take no effort at all. And then 1, depending on the problem, can go from easy to impossible if your function is not, if it doesn't have an inverse, then obviously you're not going to be able to do this procedure. But they can get difficult pretty quickly. So we'll walk through one. Just trying to keep an eye on time here. Yeah. Well, I'll go ahead and do one. So first you're going to write your function as f of x equals something. That's usually, we're almost always writing things in function notation. This is one of those times where we don't want function notation, we want equations. So what you're going to do is you're going to rewrite your f of x as a y. That's step 1. It's super easy. You just, where you wrote f of x on the previous line, you now just write y. That's the only thing. So that's easy, right? Okay. Step 2, you're going to scan through your problem, and everywhere you see an x, you're going to turn it into a y. Everywhere you see a y, you're going to turn it into an x. And being crunched for time, I can't quite explain why that works, but it has to do with that relationship we just looked at, where when you reflect across the line y equals x, you're effectively flipping your variables. Well, that's what we're doing algebraically. You're flipping the variables. We're just doing it algebraically rather than visually and geometrically. Okay, step 3 is where the magic happens, right? This is where you actually either succeed or fail in finding the inverse. Step 3 is just solve for y. So in an equation where it's easy to solve for y, that's going to be easy to do. In an equation where it's very difficult to solve for y, it's going to be harder to do. So I'll do an example in a minute and I'll walk you through that. And then step 4 is very easy. At the end where you have your y solved for, you just turn it into this notation, f inverse of x. So that looks like an exponent. You go, that looks like f raised to the -1 power. It's not. We don't use that notation for functions. That's just the notation we mean for f inverse. And you might go, well, that seems like a poor choice. There's actually good reasons why we use that, but we won't be able to have those kind of discussions, until you, like, those of you who are getting a math degree, you'll have those discussions, but we don't really need it for what we're doing. So, in fact, I think for the sake of time, I'm just kind of going to walk you through the one they have here. Finding the inverse of a function. So there's a number of examples here. I'm just going to walk through the one where they do it for f of x equals x plus 2 over x minus 3, and we want to find the inverse of that thing. Okay, so step 1, all they did was instead of writing f of x, they just put the letter y. All right, that's easy. That's easy to do, right? You literally are just, instead of writing f of x, you write y. Okay, now what? Next step, step 2, interchange the x and y's. Okay, so see how this y became an x, and these 2 x's became 2 y's? That's all you do. It's like simple, right? Like just rewriting stuff. Okay, now we get down to business. Now we have to solve for y. Now there's a couple problems here. One, there's a y in the denominator of the fraction. That poses an issue, not a huge issue, because we're going to know what to do. At least I know what to do, and you will all know what to do in just a moment. The other issue is that there's 2 y's. How do I solve for a y when there's 2 of them? And the answer is just get them together, and then you're going to factor them out into a single y. So we'll do that in just a moment, right? So what are we doing here? We're going to multiply both sides by y minus 3. So you can see both sides have a y minus 3 on them now, this red part. Okay. And as we do that, we end up with x times y minus 3, but over here the y minus 3's cancel. So that solved our first problem of the fact that we had a y in the denominator. Not anymore, we don't. All right. Okay, great. We're getting better. So now we're going to distribute the x in. So you get xy times negative 3x. That's what we have right here. And then you've just got your y plus 2 on the right. So now what you're going to do is you say, I want to collect all my y terms together. And anything that doesn't have a y term, I want to get that by itself. So one side of the equation, we're going to have anything with a y gets put on one side. Anything without a y gets put on the other. And you can see that's what happened here. And by putting it there, I mean you subtract or add appropriately to move things around mathematically. It's not wishful thinking. I can't just say, I wish you to be on the left side now. That doesn't work. We have to mathematically operate on it to get it over there, right? So I'm gonna, let's see, I want to add 3x to get this thing moved over to the right, and I want to subtract y to get this thing moved over to the left. So see how we have all our y terms on the left and all our non-y terms on the right? Well, that's great, because now, remember I said our second problem was that we have two y's, but we only can have one if we're going to solve for y. It has to be y equals, not y equals some stuff with a y. That doesn't make sense in mathematics. We avoid it as much as we can, because it would be the same as, like, when you solve for something, you're trying to define that variable in terms of another variable. But if you have a y on both sides, then you're defining y in terms of y, which is confusing. That would be like looking up a word in the dictionary, and it uses that word to define itself. You'd go, okay, that's not helpful. Like, why would you tell me that's the definition using the word that I'm trying to look up? If I knew the definition, I wouldn't have had to look up that word, right? So see, we have two terms with a y in it right here, and then we just factor the y out. Boom, now we only have one y. So no y's in the denominator, and only one y total, and then you just solve for it, and you get this. So it looks confusing the first time you do it, but once you've done 2 or 3 of these, you're like, oh, I get it. It's kind of the same thing every single time. Okay? So that is inverses. They take a little bit of practice. Learn the other ones. Don't only learn how to do the rational functions, but the other ones are actually much easier. Inverses are one of those things that there's not too many that are like reasonably difficult. A lot of problems are either really easy or they get crazy difficult. Like you can get into inverses that are very difficult to solve for, but we're not dealing with them in this class. Okay, so that's 2.7. 2.8 is about circles, and here's the quick thing on circles. I will have that video up later today, so I go more in depth with an example of it. So if you need to go back and look, I'll have a worked out example. But the main thing that you need is 329 is this formula right here. Oops, that's our definition. That's down here is what I wanted. There we go. That's what I was looking for. So the standard form of the equation of a circle with radius hk and radius r is x minus h squared plus y minus k squared equals r squared. Now that looks confusing, but if you look at it, that's helpful. That means the center, the values for the center of our circle are actually in our formula. That's really helpful because that means we can know where our circle is located just by looking at it. And then also our r squared, the radius of the circle, is right over here. So let's just look at some examples. So let's jump back into Desmos and let's look at some examples. Okay, here we go. So according to our formula, according to that formula that I just showed you on page 329, I can't show you both at once, but that says that our center should be at 2, -3, right? And sometimes students get confused by this because they get confused between the pluses and minuses in this formula, but it's x minus the number. So we think of this as y minus the number that we need. In fact, it's helpful to think of this as minus -3. Because then you go, oh, then I'm looking at 2, -3 is the center. And if we look at it, sure enough, 2, -3, that's the center. Yeah, that looks like the center. And what's our radius here? 3, which is the square root of the number that's over by itself. So the number that your circle is equal to is the square of the radius. So basically in this case, and we don't write it as -3, I'm just saying that's how you think about it. We would write it as plus. Basically what you do is you look for the center, you put your center here, and you look at the radius, and then you just count out for the radius how many spaces you need to go to complete the circle there. And then you make your circle. You will have to do this on the test, and there's one complication. I don't want to go over it. Let's see, what do we have, about 20 minutes left? Actually, technically 15 minutes because I'm supposed to give you a break. For the sake of time, I'm just going to wait and I'll post that video where I work through a whole example. But the difficulty, what you're going to have to do is more like on page 332. Like you'll have a variety of homework problems, but on the test, I give you a problem just like this, where I give you, this is not in that standard form. This is in like a general form. So you're taking it from general form to the standard form. See how when I look at it, the equation in this form, I can't see where the center is, and I can't see where the radius are. So the goal is to take it in the equation written this way and turn it into that form that we looked at, like this, where it's in that nice clean form where I can see the center and the radius. And the way you do that is with completing the square. You'll see me do it in the video that I post later today. So the whole thing is you have to use completing the square, use completing the square on the x's, and then you use completing the square on the y's, and then you get it in this form. And sure enough, look at it now. When I look at it, I go, oh, this center is at -2, +3, and it has a radius of 6. See how I can pull those values right from here? It's super convenient. So on the test, I'm going to have a blank graph for you, so you don't have to draw your own graph or anything. I mean, you'll have to draw the graph of the circle, but I give you like a grid for you to graph on top of. But I will give you an equation like this. It won't be this one, but it'll be a similar one. I give you this equation. I say put it in the proper form, tell me the center, tell me the radius, label them, and then graph it. So one of the things I see people do is like you want to slow down and like reread the question, make sure you've answered everything that I asked. Because sometimes, like on this question, when I say put it in standard form, tell me the center and the radius, and then graph it, what'll happen is people will just graph it. Well, you only did one of the, 3 things or 4 things that I told you to do, so you're going to end up missing points. Even though you probably knew what was going on, you just didn't slow down and answer the questions properly. So whenever I say, like, find this, tell me that. And then also you should label them well, right? Like in this example, tell me, this is the center, this is the radius. If you just give me a number like 6, do you know that's the radius? I'm not sure if you even know what's going on. So just label them for me, and then you'll get full credit. So just kind of slow down, read the problem, make sure you've answered everything. When we get to the test problem where we talk about asymptotes, I'll give you a rational function, and I say, tell me all asymptotes. And people will put like 2, 3, and 7. Well, first of all, that's not even how we describe asymptotes, but then it's not clear to me, do you know which one is the horizontal asymptote and which ones are the vertical asymptotes? Do you know the difference? It's not at all clear, so you end up losing points. So make sure that you're labeling things correctly. Make sure that you're, it's like if you're in English, there's kind of the idea you need to be writing complete sentences, right? It's the same thing in here. You need to be writing down complete answers in order to get full credit. So make sure you're doing that. And basically be able to do something like example 6 for the test. Okay? Okay, about 10 more minutes. The class goes till 1:50, but I'm supposed to give you a 10-minute break. So we usually just take the break at the end, unless we absolutely can't. So I'm going to get started on chapter 3, and then like I said, what I'll be doing in the coming days, in fact, I might not even have time to that, but in the coming days, I'm going to post over the weekend, be posting the videos, more sections of chapter 3 will be popping up, and so that by, certainly by the next time I see you, all of chapter 3 will be up and available for you, okay? I don't want to spend a lot of time on 3.1. It's kind of stuff you've seen from algebra, although I'll go over it actually since we only have a few minutes. Maybe that's a good way to go over it. Where's the book? Here it is. I want to get to... Okay, so here's the thing about quadratics, because a lot of this is review, but some of it's a little bit new. We a lot of times want to do a thing called optimization, which is basically where you come up with the best value, right? So you want to optimize profit. You want to minimize cost. You want to maximize, enjoyment of a roller coaster that you're designing or whatever, right? You want to maximize the gravity when it goes into its drop, or whatever it is that you're trying to do. You want to be able to maximize and minimize things. And this is a lot of what you do in calculus, is you're maximizing and minimizing certain parts of functions. And remember, we talked about that last time, maxes and mins, the relative max, relative min, global max, global min, all those. Well, if we look at parabolas, what do you get? Well, you have two, in this sense, you have two types of parabolas. Whoops, what happened there? That was weird. Here we see two types of parabolas. Parabolas that open up and parabolas that open down. Yes, you can have parabolas that open left and right, but they are not functions. So we're not gonna really worry about maximizing those, because what would that even mean? If you think about it for a little bit, it gets kind of weird. But the good thing about these is that a downward opening parabola, like the blue one, that has a maximum, doesn't it? And the upward opening parabola, that has a minimum. So that's great. That means if I have something like the red graph, I could minimize, I could find the minimum value. And if I have the blue one, I could find the maximum value. That's great. If I have a cost function, I probably want to minimize it. If I have a profit function, I probably want to maximize it. These can help us figure out like how to optimize things in general. So what you want to notice is that the minimum for my upward facing parabola and my maximum for my downward facing parabola happen at a special point called the vertex. The vertex is the point that occurs on the line of symmetry for the parabola. So there's a line of symmetry, right? If you took the parabola and you folded it right, it would line up on itself. That crease going through your paper is called the line of symmetry. And the part where your graph hits the line of symmetry for a parabola is called the vertex. And that vertex is your max or min. So if you're trying to maximize or minimize a function that is a quadratic, it's real easy. Just find the vertex. Okay, so with that said, let's get to, which one do I want to do first? Okay, 350. There are actually a couple forms that your quadratic can be in, and one is called vertex form. So graphing quadratic functions with equations in vertex form. So if your function is in this form, you may have noticed earlier I was using this form when I was graphing parabolas and showing the transformations. We're moving them around because it's the easiest. It's, again, really easy. When I look at this, I know where the vertex is. I can see this A. It tells me lots of stuff about it. But the vertex, it tells you right here on number 2. The vertex of the parabola is going to happen at HK. So when you look here, if we have something in this form, the vertex is at HK. So let's go over here and say, let's make it look like that. So if I go y equals 2x minus 3 squared plus 7. So where do you think the vertex is? Well, my h is 3 and my k is 7. So my vertex, let's see, my vertex should be at 3, 7. Let's see, is that where it is? Yep, there it is right there. So see how we were able to figure out the vertex before we even saw the graph? Really convenient. So that's what they're talking about right here in the book, is that if you have it in what we call vertex form, and it's not that hard to put in vertex form, you just do completing the square. And there's examples in the book, like where do they do it? Somewhere in here they do a problem where they do that. There's an example in there anyways. Then you can get your h and k values for your vertex just straight from the formula. This is like really easy to do if you're in that form. Okay, well what if I'm not in that form? What if I'm in the traditional form where it's what we call ax squared plus bx plus c form? Well, there's an easy way to get that one to work too. So the vertex of a parabola that's in this form happens at where x is equal to negative b over 2a. And that b and a are the ones from your problem. So they're the coefficients that come from here. So you take b, which is the coefficient on your x term, you put it over 2 times your a term, you make it negative, that's the x value for the vertex. And sometimes people get confused by the second piece. They're like, what's f of negative b over 2a? Well, think about it. That's just where you take negative b over 2a and you put it into your function. All that means is it's the y value that you get from that x value. How do we always get y values? Well, you put it, not always, but most of the time, you have an x value, you plug it into your function, and you see what the y value is. So that's all you have to do. So negative b over 2a is a really easy way to get the x value of your vertex, plug that into your function, figure out the y value, you now know where the vertex is for your function. So either one of the two forms that your function comes in, it's real easy to find the vertex. Okay, it's real easy to do. And they have examples for all of these. They go a lot more in depth with like graphing the whole thing, but again, that gets to be a little bit much because most of the time people are going to graph, going to use a graphing utility to graph stuff anyways. So that's kind of the only stuff I wanted you to know about. And then just be careful. I would read example 7 in the book on page 360 before doing the homework, because they have a nice picture in there that kind of helps explain to you a couple things you want to know. So I would read through example 7 before you do that. If you do that, you're probably good to go. And I cannot in 3 minutes talk about polynomial functions and their graphs. In fact, I have that's some of the videos that I'm going to be going over, because that's where things start to get a little bit more complicated. Starting with 3.2, the level of complexity when we talk about polynomials is going up. 3.3, we talk about division of polynomials, gets a little bit more complicated. And then 3.4 is, some people think, the hardest section in the whole book, which the first time you see it is reasonable. Here's what I'm going to say about dividing polynomials, right? And I guess I'm going to put my grumpy old man hat on. It's not as bad as people make it out to be. It's long division, and I think, you know, I think there's this stigma with long division as like it's kind of one of the stereotypical things that people don't like about mathematics. Yes, long division is not fun. Like no one gets up in the morning and says, "Oh, I'm gonna go do a bunch of like polynomial long division today." No one's ever said that, right? But it's actually not that bad. You're just subtracting polynomials off and keeping track of what you've subtracted off. So dividing polynomials is not that tricky. So, you know, I would say just kind of, you know, get yourself mentally prepared for it and work through it, and you'll be fine. And I can help you with it if you need help. You can get help from the tutors. You can help each other. But it's, I think people kind of psych themselves out. It's the same thing where I see people talk about like fractions, and they're like, I can't do fractions. And it's like, I'm watching you do fractions. You can do them fine. But they kind of have this mental block about it. So just kind of tell yourself like it's not going to be too bad, and then you'll work through it. And if you need help, you can get help from me and other students, and we'll get you all taken care of. Polynomial, here's the thing. There's two types of polynomial division. There's polynomial long division and there's synthetic division. People like synthetic division, but there's problems with synthetic division. So you can learn synthetic division. You can do those versions if you want. I tend to stick to the long division, and here's why. Polynomial long division will work every single time you try to do it. Assuming the things that you do are correct, it's going to work. Okay? Synthetic division works sometimes. It only works in specific cases, and there's a lot of regular use cases where synthetic division falls apart. So yeah, synthetic division is nice when it works, but you kind of have to remember the procedure. And then the problem is, what if you come across a problem where it doesn't work? For instance, if we were dividing a polynomial by 2x minus 1, you're not using synthetic division. It's not going to work. So that's why I just always like to use polynomial long division, because I don't have to sit there and, first of all, I don't have to remember a second formula. Like when I use synthetic division, I usually have to remind myself what it is because I don't use it very often. So I have to remember what the procedure is, and then I have to remember like when I can use it and go, is this a case where I can use synthetic division? Oh, it's not, darn it. Well, now I need to remember polynomial long division. Well, that's the nice thing about polynomial long division, is it's much easier to remember how to do it once you learn it. And then also it works every single time. So you kind of have two division methods you have to learn in 3.3. Synthetic division we have to teach you, and books seem to really like it. I don't know why everyone gets so excited over synthetic division, considering that it has some pretty big flaws to it. Sure, it's not quite as tedious as the long division, but like, I don't know. Anyways, so feel free to learn synthetic division, but you have to learn the long division because sometimes that's your only option, right? If the synthetic division isn't going to work for you, then because it doesn't hold in that case, then you have to use the long division. So you're going to have to learn that one anyways. But it's actually not bad. There's a couple little details. One is what do you do when you have a term missing from your polynomial, and what do you do when you have a remainder? How do you write the remainder? If you get those two details taken care of, polynomial long division is not that hard. Okay, right. So there we are. So we'll go with that. So I'll be posting some videos, like I say, chapter 3 in the next couple days. Those sections will come up. You know about the tests. You can plan your test, when you plan to take it, all that kind of stuff, and then we'll go from there. So that's where I'll leave off. And then as always, I'm going to shut down the Zoom meeting, and anyone who wants to talk to me, I'm going to shut down the YouTube stream, and anyone who wants to talk to me in Zoom, please come do so now, and I'm happy to answer your questions for you. Especially since I'm not going to see you again until Tuesday. So feel free to hop in there, ask me questions, and today's Thursday, right? Is today? Yeah, today's Thursday. So yeah, enjoy the weekend, everybody. I'll see you later.